I think that 26 was a little off for mine, so I think I can fix it. I think when it printed, it like printed a little off of mine. But the equation of that one should be y equals negative 2/3 x plus 1. This one's Number 2, you should be finding the slope and subtracting 3 minus 3 over negative 3 minus 4 to get 0 over negative 7, which would just be 0. Number 3 is not something we talked about.
Wait, can you go back? No, to the graph.
Excuse me. It should be the purple line. The black line was wrong on mine, I think. You guys are full good. Some of the papers yesterday got off, so never mind. This would be...
Yeah, that's how I was confused.
Okay.
But it would still go,
The slope would still be the same, but the y-intercept.
but it wouldn't flip though? It's not negative, because...
It's still negative 2 over 3. The y-intercept is different.
No, because I put 3 over 2.
Yeah, it should be negative 2 over 3.
So
it was right?
thank you.
But number 3 is something we have not talked about, so I'm just going to briefly explain what this is and what you're doing. So here you are using exponent rules. You are dividing 3 and 27, figuring out what that is as a fraction. And then if you have like bases, you are subtracting your exponents. So 9 and 4, these both have C, so you would subtract. These both have D, so you would subtract. And then another exponent rule is if you have a negative exponent, you're going to put that in the denominator or flip it. So the final answer for that one would be C to the 5th over 9D to the 4th. Number 4, when you distribute and combine all of your like terms, you'll get 12x minus 14. And number 5, when you graph, this is one of your inequalities. So this would be a dashed line because it's not included. A vertical line because it's x, and then shaded to the right. Questions on any of those? If you have your notes from last class, I would say take those out because those will help you with the notes for today. And then everyone should have these notes in front of them. We're going to start these. There is a way to do this on your calculator, and later I'll show you that. So if you want to grab your calculator, you can do that. But I'm also going to show you how to do it without the calculator. So the calculator will just be if you want to check yourself later. So with each of these, we are comparing this to the parent function, and we're trying to figure out Now we've been given the graph and we have to find what the equation of this graph is. So we're going to be looking at the transformations and seeing what happened, what changed in order to find our equation. It may help you, I'm not going to do this for every single one, but this first couple I'll do this. If we draw our parent function, so you could put your parent function in the calculator and figure that out, but I'm going to show you a trick to kind of remember this, how to visualize it. For your quadratic functions, those are your U-shaped functions. Your U-shaped functions always start at 0, 0. And then if you go 1 to the right or 1 to the left, you're always going to go up 1. So it would be 1, 1, and negative 1, 1. And then when you go 2 to the right or 2 to the left, you're going to go up to 4. So it would be 2, 4, and negative 4. So that's your parent function, x squared. We talked about that whenever we were last doing transformations. We are now looking at, compared to this parent function, what did this one that's graphed do? Yes, it translated to units to the left. Now we don't need to know all of the math lingo for this. We can just keep it short and simple, left to, but it is good that we know that it was translated and the direction and the units. So that's all that happened to it. We now need to remember, is left a horizontal or a vertical transformation? That's vertical. Horizontal. So if it's horizontal, is that going to be an inside function or an outside function? Not outside? It is inside. So this would be a horizontal inside transformation. Now that we know those two things, and we know our parent function is x squared, we're going to put these pieces together and write our function. So start off f of x. Because this is an inside function, we're going to need parentheses. Left 2, how would we write that? X plus 2, because it's always opposite. And then there would be a square on the outside. So we're looking at what changed from the parent function, looking at the transformations, using those transformations to write an equation. Before we continue, what questions do we have on that one? For here? Yeah, left 2. Any other questions on this one? Okay, for number 2, this is your absolute value function. But I have.
No.
Oh, those are.
That's crazy. And I guess they had school today, but
I don't really know how that works because they're both for today, so.
At least he has 2 hours.
For your parent function absolute value, this one would also start at 0, 0. And when you're drawing the lines of your absolute value, you can think about slope. If nothing happens to it, your slope is 1 and -1. So on this side, you go up 1 to the right 1, up 1 to the right 1, and I say do that like 5 times. And then on the other side, we're going to go up 1 to the left 1, up 1, left 1, and do that about 5 times. So if we are looking at the one that was already there compared to our parent function, what changed? Did it move to the right? It moved to the left. Because it's going this way. So it's still left 2, which would still be horizontal, which would still be inside. And since there's nothing else that happened to it, we can start writing our equation. So this would be f of x equals, in this case, because we have our absolute value, we don't need parentheses, because anything inside would be inside the absolute value. And just like this one, it's the opposite, so it'd be x plus 2. And that would be our equation. What questions do we have on that one?
What's the difference between 1x and x?
You mean like if I put a 1 here?
Oh,
Is that what you're asking?
so, oh, those are brackets, okay.
Yeah, these are absolute value bars.
Cool.
Yourself.
On the chart.
Yes, the one that's already put on the chart, and we're just trying to figure out what changed from the parent function. So I'm going to stop drawing the parent function. You are more than welcome to continue drawing the parent function, whether it's this one or this one. We're really just going to focus on these 2 functions. There are others, but those of you moving on to algebra 2 will deal with those then. For number 3, which type of function is this, quadratic or absolute value? Absolute value. Even though it's upside down, it's still absolute value. So knowing which type will help you when we go to write the equation. And then visualize this or draw it on your graph. If we're looking at this compared to the parent function, what changed? Flipped upside down. Anything else changed? Look at where it is, and look at where the parent function started.
Isn't it supposed to be on the y-axis? Will it be like a mirror by any chance?
You're talking about when it flipped? Yes, that part did happen, but if it only flipped, it'd be right here. So it did something else too. You would have to figure out what. What are you going to say? Yeah, that's what I'm. So if I look at the vertex of this, the point in the middle, that's right here, not right here. So what else did it do? It moved up. 5. I'm just gonna put the 5. Okay, so did both of those things. Flipping upside down, would that be a vertical or horizontal transformation? Vertical. So if that's vertical, is that inside or is that outside? Outside. Up 5, is that inside or outside? Is it vertical or horizontal?
Outside.
It's outside because it's vertical. So now that we know the two things that happen, this is going to start off f of x. You could also put y equals, those are the same thing. The flip upside down is your reflection. That's the negative on the outside. So this would equal a negative. Then you have your absolute value of x. Up 5, how would we write that? Plus 5. Outside of the absolute value bar. And then let's say that looks right, but you're not 100% sure you want to check it. I'm going to cover this up for 1 second. If you were to put this in your calculator, this is, I don't know. So if you were to put this in your calculator, you could look at your table or your graph. The graph may help you, but you have to look at each of the points and make sure they match. The table will help you a little bit better because you can actually see the points. So if I'm comparing, I have the point negative 2, 3. That matches. The point negative 1, 4. That matches. The point 0, 5. 1, 4. And then 2, 3. So as long as all of those match, then you're good. If they don't match, something you put in is incorrect, and you have to go back and see what that is.
So you have to put that in each one.
No, that's just if you want to check yourself. You do not have to check yourself. It is a good practice.
Okay.
Yeah.
Preston, you with me? You with me? Okay, your parent function is like right there, right? 0, 0. If you forget.
So for number 4, is this a absolute value function or a quadratic function? Quadratic, so your x squared. And comparing it to your original, what did it do? Say that one more time.
Moved up into the side.
How many?
One up 3.
Of 1 to which side?
Transpaces to
And so with those two things, up is that inside or outside? Is it vertical or horizontal? Up is vertical. So if it's vertical, that's outside. Right is horizontal or vertical. Is right horizontal or is that vertical? horizontal, so that would be inside or outside. Inside. So any vertical things are outside, any horizontal things are inside. So when we go to write this, we'll need to write the inside things in parentheses because it doesn't really have something to show inside. So f of x equals, I don't know what happened there. And then on the inside, how would we write? Right 3. Not plus. X minus 3 because it's opposite.
Just look at it.
Not everything, just the horizontal things. So if it's going right, you really write minus. If it's going left, you write plus.
Oh, this was very good.
And then up 1, how would you write that? Plus 1 on outside of the parentheses. Outside of the parentheses. So x minus 3 inside squared plus 1 on the outside. Question on that one before we do 5? Which type of function is this? Absolute value or quadratic? Absolute value. And think about where the original would be start at. What changed? Did flip upside down. Did move left 2. And it also moved down. So sometimes you'll have all 3 or all 4. It just depends on the function. Flips upside down, is that vertical or horizontal? Vertical, because you're flipping it over the x-axis. So is that inside or outside?
Outside.
Vertical is outside. Left 2 would be inside or outside?
Inside.
Inside because it's horizontal. I put outside, I put in. And then down 1 would be inside or outside?
Outside.
Outside because it's vertical. Now that we know those things, we can use them to write our equation. So f of x, how would we write that it flipped upside down? What would show that? We would have that negative, yes. On the outside. Left 2, it would be plus 2, I think someone said that. But inside. Not parentheses, since it's absolute value, but inside the absolute value bars. And down 1, how would we write that? Minus 1. Outside of the absolute value bars. Questions on that one before we continue? Number 6. This is another absolute value. What transformations do you see, or what do you think changed? It did get wider, so that's going to be was vertically compressed by something, and we'll figure that out. Did they do anything else? Okay, down 6. Anything else? It also flips upside down. With absolute value, it's really easy. I should say once you get the hang of it, it'll be easy to figure out your scale factor because absolute value is like slope. So if you look at the points on your line and you count the slope of that line, that will tell you your scale. So now we have to think, how do we find slope? Remember that's up or down and then right or left. What would the slope of this line be? It'd be negative 1/3 on one side and then 1/3 on the other side. The negative doesn't really matter because the scale is just going to be 1/3. So once we have all of those things, then we can write our equation. If we have, this would be a vertical compression. We won't be dealing with horizontal compressions and stretches, so you can assume that it will be vertical. So this will be outside. Down 6 would be inside or outside? Outside because it's vertical. And then flip upside down would be inside or outside? Outside again. What this means is there will be nothing inside the absolute value signs. Everything will be outside of those bars. So this would start off f of x equals, what would go first? The negative. And then the 1/3. And then missing something. It will be -6, but we're missing something. The absolute value part, yep. And then -6 at the end. Once you have a lot of things, especially if you have scale factors, I would definitely check this in your calculator just to make sure you're on the right track, that your scale factor is the right numbers. Like I said before, absolute value is easier to see the scale, but when you change the scale in quadratic, that may be something you really want to check. So we won't check it for this one, but we'll check it for the next couple. For number 7, what type of function is that? Quadratic, your x squared. If you don't remember what it's called, you can just say x squared, that's fine. And compared to your original, what happens is, to do that, did it move down? Yeah. It didn't move though. It moved up. Correct. It did something else. Look at your parent function or think about your parent function compared to this. was different. I'm going to draw the parent function on here. What did you say? What did you say?
Therefore, that's fine.
Okay.
That's more.
Oh, is that small?
Yes, got narrow, so there's a scale factor. It was vertically stretched. So with your scale on a quadratic, you have to kind of compare your y values from the original to the distance of what they are now. So usually you go up and over one, and then up 3 to the right one. So there's a difference of 1 and then 3. Here, between the vertex and the first set of points, the difference is 2. We're going down 2. So I would say that our scale is 2, but I'm also going to look at the difference here. There's 1, 2, 3, 4, 5, 6. The difference is usually 3, but now it's at 6. So that also confirms that my scale factor is 2. I've multiplied everything by 2, basically. And I'm going to show this in the calculator also. These, again, would all be outside things. Flipping upside down, up 2. The scale is vertical, so these are all outside. So we would start this off, f of x equals, what would go first? Negative 2. And then what? The parent function, the x squared. Not the absolute value because this is a quadratic. There's nothing inside, so I don't need parentheses anywhere. And then plus 2. So I'm going to put this one in our calculator just to make sure that we did the scale right. Negative x squared plus 2. And then I'm just going to compare some of the values. So we have negative 2, negative 6. That's right. Negative 1, 0. That's right. 0, 2. 1, 0. And then there should be 2, negative 6. Yes. So anytime you're not sure, especially with scale factors, double check it in your calculator. Okay. We're just going to do a few more and then have to practice. So stay with me for just a few more problems. Yes. For number 8, what type of function is this? For 8.
Oh, no, quadratic.
Quadratic function. Yes. Ask, whoever just left, as soon as one of them get back, you can ask Miss Rose to get back. What happened to this? What changed? This flip. What else? How many? Anything else? Ms. Martha, can you write both of them a pass? Can you write them a pass for the bathroom? Okay. So everything except left would be outside. Your left would be inside. I'm just gonna write that one. Everything else is outside. We do need to figure out the scale for this one. And again, you can look at the difference between the vertex and the first point. Here, that difference is we're going down 2. But because this is getting wider, because this is getting wider, whatever the number is has to be a fraction, because that's the only way it compresses. It's shrinking away from the y-axis. Even though we know this difference is 2, it's going down 2 from those points, it would really be 1/2. So whatever scale factor you find, make it a fraction by flipping that and putting it over 1. So if the difference was 3, because it got wider, the scale would really be 1/3. And you can look at all of those numbers like that. How would we write this? F of x equals -1/2. Parentheses, and then x plus 3.
Minus 4.
Plus 4 on the outside. So sometimes you'll have some problems that do everything. They flip and they compress or stretch and they move right or left and they move up or down. Stuff like that, I would definitely put in your calculator. Just double check it because you could have easily messed up something. So if I put that in, -1/2 times x plus 3 squared plus, what was the number? It was 4, okay. I was thinking that was not right. And I look at my table. Some of these are fractions. I'm going to avoid those and just look at the whole numbers. So I have -5/2. That's a point. -1/2. Let's get this one, -3/4. And I'm sure if I check these 2 points, they won't follow. So 1, -4, and then -7, -4, whatever point that was. So that did work. That was right. Do we have any questions on that one, how we got any of that? Because I know that one was a lot. Let's do these last two, and then you'll have time to practice. So number 9, which type of function is this? Absolute value or quadratic? Absolute value. And what changed? Went down 4. Left 1. Anything else?
Stretch.
Stretch by 2. So in this case, it wouldn't be a switch because it's right side up. If it was upside down, then we could say it was switch. Okay, so how, besides the left that's inside, how would we rate this? What would we start with?
Parentheses.
In this case, we wouldn't need parentheses because they're absolute values, but we need something else before the inside piece. 2. Then our absolute value sign. Left 1, how would we write that? Not minus, but plus. And then down 4, how would we write that? Minus 4. Last one. This is which type of function? X squared. And what happened to it? It flipped. I'm just gonna write flip instead of writing all of that. What else? Up. I think it's 3, yeah. I did one other thing.
Stretch.
It is stretch. And if you're looking at your vertex and looking at one of these points, the difference between those is what? There we go, 2. So this would be a stretch of 2. And you can also compare it here. This goes down 1, 2, 3, 4, 5, 6, and it usually is 3. The flip and the up, moving up, and the stretch would all be outside things. So how would we write this? -2. We don't need parentheses here. X squared and then plus 3. So there is a back to this, but those are the next set of notes, so don't worry about those. Everyone should have a stapled bunch of papers. Those are a bunch of different graphing practices where you're given the graph and you have to find the equation. I would say try a few from each page. If you want specific ones, I can find ones and have you do those. But do as many of those as you feel like you need, and let me know if you need help